And the reason we focus on the pancreas, because it is the source of at least 3 important hormones. And obviously, as you remember from signal transduction, most of our metabolism is dependent on the levels of various hormones in the bloodstream, whether you have high insulin or you have high glucagon. So the pancreas is the source of 3 important hormones that regulate metabolism: insulin, glucagon, and somatostatin. We'll mainly talk about insulin and glucagon in the context of their ability to change and regulate metabolism. So hence the importance of the pancreas as the source of these hormones. Another important consideration in metabolism is what's available in the bloodstream. Is there a lot of glucose? Is there a lot of amino acids? Is there a lot of tags in the form of chylomicrons? So that determines what metabolic pathways are activated and or inhibited. So that's very important consideration. Level of hormones, level of substrates, if you want, energy substrates in the bloodstream. And third, there's important input from the nervous system. The nervous system, through the hypothalamus, will direct the release of specific hormones like cortisol, like norepinephrine and epinephrine. And all of these can contribute to the overall regulation of metabolism. Okay? So input from the nervous system is very important. This is specifically important in trauma, stress, fight or flight conditions. The input from the nervous system is extremely important. So that will affect metabolism significantly, and we'll cover some of that. In the well-fed state, elevated glucose in the bloodstream will trigger the release of insulin from the pancreas. Insulin will specifically increase the uptake of glucose by muscle and adipose tissue. In the liver and muscle, insulin will activate glycogen synthesis and glycolysis while inhibiting glycogenolysis. In adipose tissue, insulin will increase triacylglycerol synthesis and inhibits lipolysis by inhibiting hormone-sensitive lipase. The brain will use the ample supply of glucose from the bloodstream, oxidizing it all the way to CO2 and producing 38 ATPs in the process. During fasting, a drop in blood glucose will trigger the release of glucagon from the pancreas. Through the hypothalamus, the brain will direct the production of cortisol, epinephrine, and norepinephrine by adrenal glands. In the liver, glucagon and epinephrine will stimulate glycogenolysis and gluconeogenesis and resupply the blood with glucose, as well as ketone bodies. The liver and muscle will switch to using fatty acids provided by lipolysis of triacylglycerol in adipose tissue. The brain can only use glucose and ketone bodies, but not fatty acids for its energy needs. If you like this video, please subscribe. Thank you.